Thank you very much. My name is Johnson Özden. I will today present the test systems that we are building in our university. I will show a few different designs and then conclude with a free running test system for submarines. This was the first real test system that we built. It was a planar motion mechanism for surface ships. The system is in order to find the maneuvering characteristics of a surface ship and also for autonomous boats. We designed it and built it. All the software is also belong to us. The second system was a free-running surface ship, which was an autonomous ship for maneuvering tests of naval vessels. Both systems are sponsored by Presidency of Defense of Turkey, and we were the designers and manufacturers, and also they are now part of our university's hydrodynamic laboratory. One other system was actually our first underwater test system. It was for resistance and self-propulsion tests of underwater vehicles. So we built this for submerged body research, but only for the axial direction. So we measured only resistance and self-propulsion characteristics. This test was done on DARPA Sabov submarine model. We got some experience on this model, and it was also a part of a PhD study and was presented in Office of Naval Research conference in Hamburg University of Technology. And the following system was our vertical planar motion mechanism, which combined our knowledge on planar motion mechanism for surface ships and for submerged body research resistant project. So we manufactured it. It was funded by a defense company in Turkey, Roketsan. So we built also the models, and the models has also their own propulsion systems and maneuvering systems inside. The system was assembled on our laboratory. We can test models up to 5 meters and has a great amplitude for sway and heave motions. And for pitch motion, there is also up to 14 minus and plus 14 degrees of pitch motion is available. Two years ago, when I was first invited to this conference, this project was ongoing, and now it is finalized and in active service now. So it is the planar motion mechanism, but in the vertical direction. And our now aim is to continue with a free running test system, which is you are very familiar actually since 18th, I think. Here you can see the Typhoon Akula submarines free running tests. Also, you generated your pump jet system also on model scale, and then to a commercial submarine and to nuclear submarines. So Russia is quite good at this free-running test technology. Also, USA is doing a lot of things with manned and unmanned scale models. They have a lake called Idaho, and they made some acoustic and maneuvering arrangements in that lake, and they are testing very large-scale models. Here is the Virginia class and the cutthroat unmanned vehicle that they are testing with a very large scale in order to get rid of the scale effects, I presume. In United Kingdom also there is a lab in kinetic laboratory. They are doing a lot of free running tests with them. Here you see the free running test of an Astute class nuclear attack submarine. As you can know, they need to check the maneuvering properties of a submarine, a newly designed submarine. So they also do have a vertical planar motion mechanism, but the design is finalized before the construction. They build these free-running models and do the tests with them. Here are the general arrangement of those systems. France is also doing these tests in model scale, not very large as Russia and United States, but they are doing tests with around 4 to 5 meter models. Here is their third generation nuclear submarine, the test system of that submarine. System has of course the rudder servo drives to steer the boat, and also the inside there are the sensors, a lot of sensors. Holland is also doing such tests, even though they decided to buy their last submarine class from France. In Marine, they are doing a lot of submarine tests, free running tests. This is a test of their Walrus class submarine. These submarines are already exist, but I presume they are doing some auto pilot software developments. So in order to, before doing it on the full scale, they are working with the small scale models. And here are our studies. Actually, at first we didn't have much funding, and funded by ourselves. We did some efforts and built this DARPA Subov model. But now we are focusing on building larger and more with high quality sensors and equipments. Our aim is to produce the system for 214 class, which is the newest conventional submarine of Turkish Navy. We will do the test with them, and then we will continue with our indigenous submarine design, Milden. So what do we have in the system? We have servo drives for each rudders. We have the propeller shaft, propeller motor, battery systems, and controllers of these motors, and also we need a cooling system in order to cool the drivers. And for submerged and surface operations, we have main ballast tanks. And the main sensor, in order to measure the speed and the position and heading of the boat, is an inertial navigation system and Doppler velocity log. So all these equipments are in watertight containers, and it is a modular design. It's a modular design, so you can use the same system with different models with small modifications. And one other project, actually, I'm an assistant professor in Istanbul Technical University in Naval Architecture Department. Also, I'm the chairman on board of Datum submarine design submarine technology company. And this company, we are now building a 12-meter mini submarine project, which will be a base of our mini submarine designs, and then it will continue with swimmer delivery vehicles, unmanned, large-scale unmanned underwater vehicles, and submarine rescue vehicles, and for civilian purposes, touristic submarines. We are doing fine right now. We already finished the detailed design of the boat, which is actually the first indigenous submarine design of Turkey before we demand on German designs. The pressure hull is completed, and a lot of equipments are also completed. So we are planning to launch the boat in December. So that's what since last year I was busy with. I wanted to share with you. Thank you very much for your invitation.
Thank you very much. Спасибо. Вы будем двигаться вперед. Может быть, один вопрос, Дженсену можно задать. Он не просто хочет иметь продукт, но борется за качество на всех этапах разработки. Что интересно, и видите, в общем-то, может быть, от стартапа дошел до проектирования, строительства больших аппаратов, и у них есть уже туристическая подводная лодка, мы увидели нам. Поэтому к этой фирме я рекомендую присмотреться. Пожалуйста, вопросы. Если нет вопросов, можете в чаты нам направить, мы Джастину отправим и потом вам сообщим его ответ. Так.